Welcome all to the analog lecture series. In the last class, I have requested you all to calculate the value of RE. How many of you did? If you found the answer, just to drop it in the comment section. Okay, let us continue. If you are doing DC analysis, in this case, just to take the same circuit, only thing what we are going to do is, I am going to short circuit the AC source. If I will short circuit the AC source, then this circuit will become, I am starting from, once again from the starting resistor. Then here we are going to consider the transistor. Anyway, this base is going to be short circuited because while doing DC analysis, AC voltage will get short circuited. And one more thing, here I told you we are considering one more diode. Why I am calling it as diode? Because I told you whenever base and collector terminals are shorted together, then that circuit will be simply acting as a diode only. Anyway, so this is the current, emitter current delivered by the second transistor. I am calling it as IE, and the first transistor also I am calling it as IE. If you apply KCL at this, then this current will become 2 times of emitter current IE. Further, if you observe, they have given one more resistor in your question. After that, here we are having some voltage. I think that is minus 5.7 voltage. I will tell you how I have taken that 2 times of emitter current, don't worry. For that, we have to observe the question. In the question, they told that two identical transistors and the value of beta is very large. So from that conclusion, I can directly make, see, go back to the question. They told that there are two transistors, both are identical to each other and the value of beta is very large. Identical to each other means almost they are going to carry the same current. That's why in both cases I have taken same emitter current. Of course, when beta is very large, then emitter current and collector current are going to be equal to each other. So here we know this is the branch terminal where we are going to carry the collector current, but according to the conclusion, emitter current and collector current both are same. So directly I am treating it as emitter current only. And while doing DC analysis, it is very important to consider the base to emitter voltage that is already given as 0.7 voltage. If you observe the question, that is already given. Now what I am requesting you is just apply KVL from base to emitter. That will be sufficient to calculate the value of emitter current. How will I do that? For your understanding, let me redraw only from the gate, from the base. Base is grounded, then we have to cross the transistor. Transistor equivalent circuit is base to emitter 0.7 voltage. Then we have to consider the emitter resistance. Current entering into the emitter resistance is 2 times of IE. You know the reason. Whereas for the resistor, current entering point plus leaving point is minus. Then they given the battery voltage is negative. Negative means minus should be connected with the circuit. Positive plate is connected with the ground. Now you can consider only magnitude. Why I am not considering negative now? See there, negative indicates that negative plate is connected with the circuit. So I have connected the negative plate. Then you no need to consider this sign. Directly you can consider plus 0.7 now. Okay sir. Now it's time to apply KVL for this equation. For the circuit. If you apply KVL for this circuit, what you will be getting? We will be starting from here. Here we are having 0 voltage. So here we are having 0.7 plus 2 times of emitter current IE minus 5.7 equal to 0. How I am getting minus? Here the starting polarity is minus, here the starting polarity is plus, here the starting polarity is plus. So plus I put minus here. Now let us reduce this. Plus 0.7 minus 5.7 will give you minus 5. From that I can say 2 times of IE equal to 5, or the value of emitter current will be equal to 2.5 ampere. Yes sir. So we understood this. Okay. Once we found the value of emitter current, actually 1 minute, I did a mistake. Actually here while applying KVL we have to write down the voltage drop, right? I simply 2 times of IE into what is the resistance value? 1 kilo ohm, that is 1 into 10 power 3. We have to consider that because see, this is simply current. While applying KVL we have to write the voltage expression, voltage drop across the resistor. So here one more 10 power 3 is there. If you pass the 10 power 3 to the right hand side, it will become 10 power minus 3. So 10 power minus 3 means we have to write that the value of emitter current IE is equal to 2.5 milliampere. That's all. So we did the DC analysis just to calculate the value of RE. I told you always we are going to redraw the circuit. That is, we are going to now I am going to redraw the AC model for this configuration. While drawing the AC model, knowing the value of RE is very important. RE is nothing but dynamic emitter resistance. I told you. Now how will you calculate the value of dynamic resistance? Dynamic emitter resistance can be calculated with the help of, I have last class itself I told you, that is VT by emitter current IE. What is the value of VT? What is the value of emitter current? Tell me. The value of VT is given as 25 millivolt. Milli means 10 power minus 3 upon the value of emitter current is 2.5 into 10 power minus 3. So thermal voltage divided by emitter current. Thermal voltage is 25 millivolt given in your question. So from this, if I will cancel it, this 2 will get cancelled out. This will become 10 ohm. While observing the first question, it may seem that, sir, I am not understanding what you are doing. It will be like that only, because you are trying to learn from the beginning. Now it will be slowly, you will be understanding. After cracking 2 or 3 questions, I am 100% giving assurity that you will be getting the complete clarity. Okay, this is the way we have to solve the question. Like that, you will be automatically solving the question. So don't be bothered. Okay sir, after calculating the value of RE, now it's time to do the AC analysis. Remember one thing, the value doing DC analysis is very simple. Directly we can do, just to take the transistor, and there are some parameters are hidden. It means while doing AC analysis, we are going to draw the circuit in a certain manner. While doing DC analysis, simply we are going to draw the circuit in certain manner. Already so far we did DC analysis in BJT. So you might have understood how to do the circuit. Directly you can take the circuit and you can do the analysis. But while doing the AC analysis, let me tell you what are all the things that we need to do. So I hope you all understood how to do the DC analysis, and from the DC analysis only we have to estimate the value of RE. Don't forget, that is the first step that you have to do. After that, slowly I will be bringing the connections between all these circuits. Okay sir, so this is all for this lecture. In the next lecture, we are going to design AC analysis for this circuit, and we are going to bring the answer for this beautiful question. So this is all for this lecture. Remaining things we will see in the next class. Thank you all.